A force is any kind of push or pull. Forces are vectors, which means they have not only a magnitude, but they also have a direction. Contact forces require physical contact between objects. A push or a pull is an example of a contact force. Friction is an example of a contact force. Field forces are transmitted without physical contact. That is, the objects don't have to be touching in order for forces to act between them. Gravity is an example of a field force. You don't have to actually be touching the Earth in order for a gravitational interaction to take place between you and the Earth. Electric forces, magnetic forces are field forces. You may have played with magnets as a kid, and they exert forces on each other even if they're not touching. In physics, we've actually combined those two types of field forces, electric and magnetic, and we call that electromagnetism because it turns out that they're very closely related, two sides of the same coin, you might say. Springs exert forces, but only when they are stretched or compressed. In other words, if you have a spring at its natural length, then it's not pushing and it's not pulling. In order for a spring to exert a force, it has to either be stretched or compressed. If it's stretched, then springs pull. They try to contract back to their natural length. If you compress a spring, then it's going to push, trying to go back to its natural length. The farther they are stretched or compressed, the larger the elastic force with which they pull or push back. This sentence is two sentences in one. We can read it one way, leaving out the words in parentheses, and then we can read it again, leaving out the words that are bold-faced. The farther they are stretched, the larger the elastic force with which they pull back. The farther they are compressed, the larger the elastic force with which they push back. Springs conform to Hooke's law. This tells the force that a spring exerts depending on how much it's stretched or squished. And that's equal to negative k times delta x. K is the spring constant. A spring constant is essentially the stiffness or tightness of a spring. Some springs are kind of flimsy. Other springs are very tight. Tight springs have large values of k. Flimsy springs have small values of k. Delta x is not the length of the spring, it's how much the length has changed. And the negative sign means that the force and the displacement are in opposite senses. In other words, if I squeeze a spring inward, it pushes outward. If I pull a spring outward, it tries to pull me back inward. So that's why there's a negative sign there. Let's summarize forces 1. 1. A force is a push or pull. Contact forces require physical contact between objects or surfaces. Field forces can act between objects even if the objects aren't touching. 2. Springs push or pull depending on how they are displaced. Hooke's law governs forces in springs. And Hooke's law is the elastic force is equal to opposite k times the displacement.